Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in a previous lecture we have started unit number 5, game theory. We have seen some introduction part of the game theory and some definitions related to game theory. And also we have seen payoff matrix in a game theory. So in this lecture we will see theorem and some problems on a saddle point. So this theorem is a very important exam point of view. There may be the question in your examination. So what is the theorem statement? Let Aij be the M cross N payoff matrix for a two-person zero-sum game. If lower V bar denotes the maximum value and upper V bar denotes the minimax value of the game, then we have to prove that upper bar V greater than or equal to lower bar V. So this is lower bar. Okay. That means we have to prove that minimum J lies between 1 to n, maximum Aij where I lies between 1 to m, greater than or equal to maximum of minimum Aij where J lies between 1 to n. Okay. So we have to prove this theorem. Okay. So let us see the proof of this theorem. So we have given maximum of Aij greater than or equal to Aij, where I lies between 1 to m, and minimum of Aij, where Aij is the payoff matrix, m by n cross payoff matrix, less than or equal to Aij for all j equal to 1 to m. Let us suppose that the maximum be attained at I equal to I dash and minimum value is attained at j equal to j dash. Now we will put I equal to I dash and j equal to j dash in both equations. Then this equation can be written as maximum of Aij equal to Ai dash j and minimum Aij equal to Ai j dash. Okay. Then we must have A dash j greater than equal to Aij and this is greater than equal to Aij dash. Okay, we can write, okay, for all I equal to 1 to m and j equal to 1 to n. So for this we get, if we take the Aij dash value and Ai minimum and maximum, then we will get minimum A dash j greater than equal to Aij greater than equal to maximum Aij dash for all I equal to 1 to m, j equal to 1 to n. And also this can be written as minimum j varying from 1 to n, maximum of Aij I varying from 1 to m, greater than equal to maximum value of I lies between 1 to m, minimum Aij j lies between 1 to n. So this is nothing but upper V bar greater than equal to lower V bar. Okay, so this is the theorem of game theory. So this is a very important exam point of view theorem, and this is a very simple theorem. Okay, so now we will see next point, that is how to solve the problems of a saddle point. That means how to find out the saddle points. So there are some rules. First we will see the some rules of the saddle point. What is the step number 1? At the right of each row, write the row minimum and ring the largest of them and mark star to the minimum element of the row. Okay, so what is the first step? So you have to you have to take the each row minimum value or largest value in each row. Okay, so what is the first rule? So you have to take the minimum value on each row, then you have to bring the largest value on that row minimum. Okay, and you have to mark as a star. Second step is select the greatest element of each column of the payoff matrix and mark them plus. And third step is if there appears an element in the payoff matrix mark star plus both the position star and plus or both. The position of that element is a saddle point of the payoff matrix. If there is a intersection of star and plus, then we can say that there is a saddle point. Okay. Now we will see the some problems on a saddle point. So the following problems on depends on determine which of the following 2% zero sum games are strictly determinable and fair. Give the optimal strategies for each player in case of strictly determinable. Okay, so this is the heading. Now we will see the following problems which is based on this heading. Okay, so we have to find out the which game is strictly determinable and not. Okay, so this is the payoff matrix. Player A using two technique A1, A2, and player B using two technique B1, B2, and this is the pay of the player A and gain and loss of the player A and B. The given payoff matrix is that is player B and B1, B2. So here we have to find out the first row minima. Row minima means take the smallest element in each row. So here is 0 and here is 0. Okay. So this is called as a row minima. Row minima 0, 0. Maximum means lower V bar. So take the largest value from this row minima. So here both are the 0. Therefore we can take 0. Then we will find out the column maximum. So take the largest value from column, first column and second column. So here largest value is 5 and largest value is 2. So minimax means take the smallest value in column maxima, that is 2. Okay. So here maximum means lower V bar is 0 and minimax upper V bar is 2. Okay. So the payoff matrix star represent the minimum payoff in each row. Okay, star means minimum payoff in each row, and those marked with plus represent the maximum payoff in each column of the payoff matrix. The largest component of the row minima represent lower V bar. Okay, largest component in the row minima which represent uh, maximum, and the smallest component of the column maxima represent minimum value, that is V bar. Okay, we have already seen the smallest element in column maxima which is called as the minimax, and largest element in row minima which is called as the maximum. Okay, you have to understood. Okay, you have to remember. So here lower V bar is 0 and upper V bar is 2. Okay. So therefore here we can say that lower V bar is not equal to upper V bar, that is maximum is not equal to minimax. Therefore the game is not strictly determinable. Therefore the game is not strictly determinable. Okay. Okay. When we say that the given game is not strictly determinable, if maximum and minimax is not equal to, then we can say that given game is not strictly determinable. Second point, if lower V bar equal to upper V bar equal to any constant value, then we can say that the given game is strictly determinable and but not a fair. Okay. Third case, if lower V bar equal to upper V bar which is equal to 0, okay, then we can say that given game is strictly determinable and fair. Okay, so you have to remember these 3 points. Okay, on this 3 point we will uh, we will identify given game is strictly determinable or not. Okay, so this is the second problem. So this is a player A using two technique and player B using again two technique. Okay. So here we have to find out that this game is strictly determinable or not. Okay. So what is the solution? The given payoff matrix for player A can be written in the following form. Player A using A1 A2 technique, player B using B1 B2 technique. Okay. First we will find out the row minima. Row minima means select a smallest element from each row, that is 0, and this is -1. Okay. So then find out the maximin. Maximin means largest value in row minima, that is 0. Then find out column maxima means largest value in each column, that is first column is 0 and second column is, that is 4. And then find out the minimax. Minimax means lowest element in column maxima, that is 0. Okay. So if you observe, maximin is 0 and minimax here is 0. Okay. So in payoff matrix, star which represent the minimum payoff in each row, and those marked plus which represent the maximum payoff in each column of the payoff matrix. Okay. So if you observe, maximin, that is lower v bar, is equal to 0 and minimax, that is upper v bar, equal to 0. The both values are 0, and hence from the conditions we can see that lower v bar equal to upper v bar equal to 0. Then we can see that game is strictly determinable and fair. Okay. So if game is strictly determinable and fair, then we can find out the optimum strategy for player A and for player B. Okay. So here the optimum strategy for player A and player B is given as A1 B1. Okay. If you observe in this matrix, so here star and plus both are combined, or intersection of the star and plus, that means there exists a saddle point. So player A using A1 strategy and player B is using B1 strategy. So this element is called as a saddle point. Okay, because here star and plus both are intersecting. Okay. So this is the saddle point of this problem. Okay. So A11 is a saddle point of this problem. Third problem, solve the game whose payoff matrix is given by. So player B using 3 technique, B1, B2, B3, and player A using 3 technique, B, A1, A2, A3. So this is the gain and loss of the players. The given game is, so this is the given game. So you can consider alpha means A1, A2, A3 strategies for player A, and beta means B1, B2, beta means B1, B2, B3 for strategy player B. You can write in this way, or you can write this problem in this way. Okay. Now we will find out the row minima of this payoff matrix. First row minima is, that is 1 minimum value. Second row minima is 0. Second minima is -4. Okay. Row minima means that is -4. Then third is, that is -1. Okay. That is -1. Here is a mistake. Okay. Then find out column maxima. The column maxima is largest value, that is 1. Here largest value, that is 5, and this is largest value, that is 1. Okay. So if you observe here star and plus, here is also star and plus. That means there are two saddle points. So maximin is maximin means lowest value in this row minima, means largest value in this row minima, that is 1. Then minimax means minimax mean minimum value in this column, that is 1. Okay. So if you observe here, maximin equal to 1 and minimax equal to 1. Okay. Star which represent the minimum payoff of each row, and plus which represent maximum payoff in each column. Okay, in this given payoff matrix. So here minimax equal to 1 and maximum equal to 1. So therefore we can say that the game is strictly determinable but not a fair. Okay, game is strictly determinable but not a fair. Okay, so again if you observe here, so this is the a1 b1 is a saddle point, a1 b3 this is second saddle point. So there are two saddle points because star and plus intersect to each other. Okay, so therefore the game is strictly determinable but not a fair. The value of the game is given as v equal to 1 because the lower v bar and upper v bar is both are equal to 1. Okay. Now if you observe from the given payoff matrix, there exist two saddle points. I already told you, having star and plus at a position a1 b1 and a1 b3 are the saddle points. Therefore, the solution of the given games can be written as the optimum strategy for player A is A1. Optimum strategy for player A is A1 and uh, optimum strategy for player is A1 and optimum strategy for player B is B1 and B3. Okay, the optimum strategy for player B is B1 and B3. The value of the game is 1 for player A, okay, and -1 is for player B. Okay, so this can be we can say that this is the gain of player A and this is the loss of the player B. Okay, so therefore the value of the player game of the value of the player for A, value of the game for player A is 1 and the value of the game for player B is -1. This is the loss and this is the gain of the player. Okay, so in this way we can find out the solution of the problems. Okay, saddle point of the payoff matrix, and then we can find out the optimum strategies of to the given payoff matrix. Okay, so example number 4 is a homework for you. So you have to solve this problem. You can see how the problem is solved. So this is again same problems. Again here one saddle point is exist. Okay, same problem. So you can solve this as a homework. Okay. So in this lecture we have seen how to find out the saddle point in a given payoff matrix, and then how to find out the given game is strictly determinable or not, fair or unfair. Okay, so in next lecture we will see another problems on this topic. Okay.